told you, let's have everybody's attention here. Remember when I told you I went scoring?
Yes.
And I learned the things that were most important for 6th graders to know to be successful in 7th grade?
Yes.
Well, I made a lesson to highlight one of those really important things. Okay, and we talked about properties of numbers, and so what we talked about with properties of numbers and what we've learned about patterns and variables and equations, expressions, we're going to use today because this is something that's super important. 6th graders really need to know this to be successful in 7th grade. Okay, so we're going to start with a focus question. Is there a reader out there? Ronald, can you read the focus question for us?
How do we know whether expressions are equivalent?
Great. So how do we know whether expressions are equivalent? And then keep reading. By the end of this lesson,
By the end of this lesson, you will be able to identify and create equivalent expressions using number properties.
great. So does that number property sound familiar?
Yes.
Nayeli, expressions sound familiar? And then equivalent should sound familiar. All right. So you've got a lot of materials in your basket. Why don't you just take a look? Find the sheet that looks like this. That needs to go on the floor. Find the sheet that looks like this. Make sure everyone has one. It might be yellow, it might be white. Make sure everyone in your group has one. So in a moment, so make sure everybody has one, you can start by putting your name, your class, and your date on it. You can put the other sheets back in the basket. That's why we want all other materials on the floor so you have space.
Can they be in a separate time?
That's fine. So make sure your name, your date, and your class is on this, please, everybody. So in a moment, I'm going to show you a pattern. I'm going to show you a pattern made out of toothpicks. I'm going to show you the first shape, the second shape, the third, maybe the fourth shape. And then your job is to create the 5th, the 6th, the 7th, and the 8th shape. What it's going to look like. So you're thinking about the pattern. What's the pattern? Build other shapes that match it, okay? So you can use the back of your graphic organizer if you need to draw out the pattern. You have grid paper if that'll help you draw out the pattern. And then there are also toothpicks in the basket. You can use the toothpicks if you like to help you figure out the pattern. You will use the toothpicks in the right way. You know what to do with them, okay? Okay, so let me show you the pattern. And, let's see, I'll show you the pattern. Oh, there's the pattern. So there are 4 different shapes there. What's the 5th shape look like? What's the 6th shape, 7th, and 8th shape look like? So I want you to draw those shapes. Also in your basket, you have pictures if this is really hard to see, okay? So I'll give you a couple minutes. I want you to draw the next few shapes. I want you to draw that in the model part of your graphic organizer. Please talk to each other to draw those next couple of patterns.
Okay, so
So the next 3 or 4, right? So that's the 4th. So what's the 5th one? What's the 6th one? Draw in this model, please. And if that's not enough space, then you can use the back. Or if you want to use the grid paper, if that you think that'll help, that you can use that too. Okay? Okay.
and the toothpick.
Yeah, you know, the toothpicks. Use them if you really think it's necessary. I know they're fun, but we need to get this done. Okay? Okay, fine. So what does it look like? So that's the, oh look, that one. That one, did you do that one or that one was already there?
Oh, you have
That one was already there, right? Do you think that's right?
So are we supposed to like draw it here?
right now.
Probably, yeah.
Miss Jackson wants you guys just to look at the shapes right now.
As I see in these pictures, it's going up by 1.
It's going up by 1. What's going up by 1?
The lines, like shapes. Yes. The sides keep going up.
The sides seem to be increasing by 1. Okay, can you draw what the next shape will look like and the next and the next? The next 3, at least the next 3.
Okay, yeah, of course.
So Maxwell, what are you doing? So there's the first 4 shapes of that pattern, right? So I used toothpicks and I created. Yep, you're going to make the 5th one and the 6th one and the 7th one and the model. Yes. Okay. So if you're using pencils, that's a good idea. Okay. Yeah. Is that okay? Do you want me to take it and I'll hold it for you and then we'll staple it later?
Yeah.
Okay. So maybe about another minute and 30 seconds to finish those 5th, 6th, 7th shapes.
What?
So just do 2 more, Jennifer. You can do 2 more.
I did them big.
That's okay, Jennifer. You can. It'll fit.
Wait, this is what I did. Mine is extra, but
Nice.
Oh, we're doing shape 7 too?
Good. So there's a number of people who are finishing up their shapes. So shape 5, shape 6, and shape 7. Okay. So I'll give you another 30 seconds just to finish. Make sure you've labeled 5, 6, and 7. And then I think your shapes will look like that.
Yeah.
Is that true?
Yes.
Okay. Now think about it privately first. What do you want to complete next? Because I'm going to ask you to create an algebraic expression, complete the table, and to write a description in words of the pattern. So you're going to complete those other 3 quadrants according to the model that you made in that quadrant. So in other words, what's an algebraic expression to represent what the nth term would be? What's a description of how that pattern grows? Make a table to show how many shapes, or the number of the shape number, and then the number of toothpicks. So think about what you want to start next, and then you can start it. And of course, you can have conversations with the people at your table about what you're doing. We'll work on this for about 7 minutes.
Six. It's shape number 6 is not 6 toothpicks. No, it's not. Count it. 1, 2, 3, 4, 5, 6, 7. Oh.
Mm-hmm.
I guess toothpicks.
All the toothpicks. Yes. What were you thinking?
I thought you just counted by 1, 2, 3.
Counting what the sides? No, we're going all the toothpicks. Okay? So work together. You can do the description, the expression, or the table. I think most people are doing the table.
So for 5,
Yeah, so tell me why you made the table this way. You count it and it goes by 2. What is it? The pattern shapes, it goes by 2. So, goes by 2. Maybe we want to write an algebraic expression. So we want variables, numbers, coefficients, and terms to create a rule or a number sentence that can predict the shape number and the number and then a verbal description. You can start with whatever one you want. So tell me why you have it. Oh, you're trying it out. I'll come back.
I finished my table, so
Alright,
I can
Johnny,
do
what are
the
we working on now?
description.
Expression or word? Description? Yeah. Okay. Yes, describe the way the pattern grows. Describe how it changes.
The pattern grows by 2.
shape 2 would be 8.
Okay. And then I want you to write an algebraic expression.
How much does 2 like, what do we see the pattern in? Like, for example, I see that the pattern goes up by 1.
So let's be a bit more mathematically descriptive.
So,
Goes up by 1. What kind of math words can you put in there?
Increase.
That's when, like,
That's
that's when, like,
Okay. And then I want you to think about putting what you said in words into an algebraic expression. So we should be focusing, moving into completing all 4 quadrants now. Algebraic expression. Explain to
Do
me.
you start with 1 or
That's how
5?
I got y equals 2x plus 100.
What do you mean if you start off?
It says shape number, right? So 1, 2, 3, 4. Do we start with 1, shape 1, or shape 5?
Because each time,
Because shape
each time
5
you look at this,
Yeah,
it goes
because
up by 2.
you're doing it based on your model, which is here, which starts with 5.
So we only do 5, 6, and 7.
Okay.
y x.
In words.
And then,
Oh, okay.
yeah. And then
So
this,
the y-axis.
and then I just used this because I just started from
Or the relationship between the number of
You got it right?
and the shape number.
How isn't it 18, 20, 22, 24?
It's 12, 14, 16, 18, 21,
Great, now write up.
23.
Okay, great. So I want you to make sure you have a description of words. Words, nice expression. So tell me about this.
Okay, so he just actually explained it to me. And so we did, so why I put y here is because it's x and y, so I did the y, because we did it from the bottom.
Okay.
Then I did 2 times, and it would sometimes add by 2, so I did.
Okay. So then I see you started at 5, and Denise, it looks like you maybe were starting at 1. Is that okay? Why is it okay? You don't seem sure, It is okay. Why is it okay?
Because it's the same thing. I just added like 1, 2, 3, 4.
You started at a lower number. Okay, let's go. Algebraic expression, description, and words. I'm going to need volunteers to connect 2 of those quadrants. So you're going to have to explain how your algebraic expression relates to your model, or how your model relates to your table, or how your table relates to your description. So I'm going to give you about 2 minutes to get ready. I'm going to maybe pick 1 or 2 people to explain. Okay? Keep working until that time.
No, I'm gonna do how the model.
You don't understand that? Did you talk to people at your table?
Nope, she never talks to
She
us.
never talked to us.
These are your first. These are the first people that you should be seeing. Well, listen, let's put that aside for now. Anika, do you feel comfortable asking?
I was doing my work.
Maybe she was doing it. Oh, sometimes she's really good at this, and so it's like, did you do that?
No, he didn't. No, he didn't.
Okay, so let's pretend like none of that ever happened, and then you can talk to all the
But he didn't do
Okay,
it.
listen.
She even said no, so I don't even know what she
I said, I don't know. I was doing my work.
I went 2. It's supposed to be from
You tried to love each other. Did it work?
supposedly.
Yeah. Okay. What is N? Oh.
Because the number of toothpicks is more than the shape.
You're right. The number of toothpicks should be more than the shape number. That makes sense. So you might need to change your expression. That's great. Okay. So, can you explain? No? Okay. Sophia, you feel comfortable doing it?
N is
You're on my radar. We'll see if you do it.
it's not plus 2 because 4 plus 2 S equals.
Hold up.
Maybe S equals.
I want to do a algebraic expression. I was really sure, but I was thinking it was like S equals T plus 2 because like let's say you have
You're adding.
the shape number was like
Yeah.
and then like T would be the toothpicks would just say
Okay.
4 from the before one.
Okay. Plus 2 more. Right. So I want you to make an expression. Just put it on paper and then check it.
Okay, but I have a question now.
Yeah.
For this one, since it's like 1, it's not like a weight table.
Well, it's like a raise. It's
Yeah, you know, like, but it's not like an equal
yes, you're right. You're right. You're right.
Equals 1 plus 2. Okay.
If you're trying to do this one, like,
You're right, Tom. It's not like a right table. You're correct.
yeah. So like S equals T plus 2, right? So if you want to find this one, you put like 1 here.
So you want, if S stands for shape, then you're going to put a 1 there, right? Can everybody see this? Can you see what Tom is writing? You can? Jalen, you might need to move so you can see. If S stands for, like, if S is shape, and then you want to say 1, and then what's T going to be? Toothpicks, okay? So 4,
4 plus 2 equals the next
does that equal 1?
No.
No. So I'm not sure that that's the right expression.
Okay.
Do you understand what we did?
And that's why Miss
Jalen, we
gave her
thought of
once
something
you
that
get
didn't work
expression,
because we
we
used the
shouldn't
number
do
from the
work.
table. Okay. So I found someone to talk to us about their shape.
Can I do
or
the
their
table?
model. That one looks good. Those look good.
Can I do the table?
So Kaylee, come on up and show us.
Teacher Kaylee.
Okay. Okay, so we got a top reader for you, Kaylee. And you're going to connect. Yeah, she's going to connect her algebraic expression to the table. You rather do it on the board? You don't want to do it on the doc reader? Okay, fine. What, the whiteboard or the other board?
The whiteboard.
Okay,
Hey,
fine.
teacher Kaylee.
Teacher Kaylee.
Okay. So my algebraic expression
Kaylee, you can write on the whiteboard. Not with that marker, though. I mean, the small board. Yeah, right on there. Right on there.
Oh, the smart board. Okay, so my algebraic expression is 2s plus 2. And I got this because the shape number, as seen on the table, we have shape number 1, and then 1 times 2 equals 2, and then add 2, we get 4, which is the total number of toothpicks. So that's how the algebraic expression relates to the table. And another example is shape number. So 2 times the shape number is 2, so that equals 4, and then add 2 equals 6. You understand? Yes, Ronald?
But don't you have to use the number of toothpicks in it?
Yeah, the shape number. And then you add 2 to get the number of toothpicks. That's how you get the total number of toothpicks.
So, Ronald, let me see if I understand what you're saying. You are missing the number of toothpicks. You're saying, how do I know it equals the number of toothpicks? So that's a great expression. I wonder, how can we represent where toothpicks would be here? Right? What do you think, Max?
You put like if you want to put toothpicks, you can put like t equals 2s plus 2, and then that would be.
Does that make sense?
Yeah.
Yeah. So Ronald, is that kind of what you were asking?
Yeah.
Yeah, so if we do like this, I'm trying to make it smaller.
Oh yeah, can we write it?
That's not gonna work. But we can basically say equals t. Okay. And that's an equation that has an equal sign. Cosentino's question, Sama question.
I was asking if I could show you.
Oh, I think we only need one for now because we're gonna move on to a second activity. This is just to get us warmed up. You have a question, Sama? What is it?
So since like it's an expression, so like, if it's an expression, so it has no equal sign, right?
Yes.
So, okay.
You're right. So what I should have written was algebraic expression or an equation.
Okay.
That would have been more clear. You're right. Does that make sense, guys?
Yes.
What Kaylee wrote at first was an expression, and now we have an equation because it equals t. Thanks for pointing that out. Okay, so now that we've reacclimated or we've acclimated ourselves to writing expression, I wonder about equivalent expressions. I'm wondering if there were like more ways to write that pattern, if there were more ways to express that pattern, right? So here are a bunch of ways, perhaps, we could have written that expression. I wonder which of these are equal to the expression that Kaylee wrote. So Kaylee gave us 2n plus 2s, I apologize. And what did S stand for, Kaylee? Shape. So if I write 2n, because all of these have n's, what might n stand for?
Number.
Shape number, right? It's still the variable. So you're right, Kaylee, you did do 2s. I'm going to write it like this for the sake of consistency because all of these have n's. Okay. So I'm wondering which of these 9 are equal to the expression that Kaylee gave us. I'm wondering. You're going to have to figure it out. Okay? So look in your basket. Have one person or hand out that hand sheet. Make sure your name, your date, your class are on
What do
it.
we do with the finished ones?
Just put them to the side.
You have it. Okay. Good. So everybody should have a sheet, and you'll also find this, I don't know, what color is this? Salmon? So you'll have this pink sheet that reminds you of the property, okay? The property that we recently spoke about. So there are only 2, so everybody doesn't need it. Maybe it's just one per pair. So let's have somebody read the instructions for us first, just so we're on the same page before we just jump in. Nayeli, can you read the instructions, please?
these expressions are equivalent to our target expression. Use mathematical evidence to support your answer and write yes or no bonus. Write what property you can use to support your answer.
Okay, just a reminder of the properties. I want to know if these are equivalent expressions. Okay, let's work. So you can write yes or no. So which one are we looking at first?
I think one is actually, because we wrote I think she wrote 2s plus 2, so I thought 2n, because the shape and the number is kind of like the same thing, so I thought it would actually be 1, and be similar to hers.
Right, and I think Maxwell used X. So it's still fine.
Yeah, we both
You
used
both
Y.
use X, great. No, you use X. X.
Oh, yeah,
2N or 2S. Okay. So why don't we do yes? Because that was the same one we used. And now what about number 2? Is that equal to our target expression?
No.
You say no, I wonder.
Yes.
You say yes, they say yes.
Yeah, I say yes.
Right, I don't know. Figure it
Yeah,
out.
because like 1 plus 1 is 2, and then
Right, and
there's
then
2
n
n's.
plus
2 n's.
So it would still be 2
n's. Duh. Okay.
You want to do the big one first and then come back and do the bonus? Okay. So the first one is obviously yes. Let's see, Amber is next. We're showing you the real yes.
3 is yes, 2.
How do you know that 3 is yes?
Because the same thing is here.
Because this is 2 times n, and then this is n times n.
Give us an example of how that's different.
Okay, look. So if, no, it's not. Look.
Because look, if n is like, let's say 5, this is the same as 5 times 2. That's 10. This, if n is 5, that's 5 times squared. Square is the number times the no, so it's 5 times 5, that's 25.
Does that make sense to you, Prashant? Can you explain it back to me? Probably not. Let's try this over again. So let's hear Amber explain it to Prashant one more time. Pay attention.
That's the same thing we just wrote. What a yes.
Let's talk to the group. Let's see if it, because some other people, so Sam was talking about number 5, okay.
Did you guys get up to number 5 yet?
No, I don't understand this.
Okay, I think, okay, so I'm up to, yeah, I finished this and I only have 2 problems. So, what I was thinking was that this is obviously Kaylee's, right, up there, so it's like yes.
Yeah.
But, and this one is also yes, because you know, like the distributive property, you can do 2 times n plus 2 times 1, which is 2n plus 2 plus 2 times 1 is 2.
So let's mark on the paper because we remember the distributor. Remember the Angry Birds? Where's that?
Yes,
yesterday.
Right, the Angry Birds, right? So remember, if we distribute this Angry Bird to this pig, that's Angry Bird times pig. And it's really the distributive property of multiplication, Jennifer. So this Angry Bird to this Angry Bird times Angry Bird. And of course, there's a plus sign because we're still adding them. Okay, so let's use it here. Multiply 2 times n.
You can't do it. Right.
Can we?
Oh, no, yeah, you can. 2n.
We can't add unlike terms, but we can certainly multiply them to 2.
2n times 2. Plus 2, sorry.
So plus 2, very good. And we use the distributive property here, okay? So where else can you use the distributive property? Maybe you want to use the distributive property as much as you can first. Here, do it here. Oh, and this is a yes.
It would be 2n, right? I did besides the distributive property.
Is this what she just said?
Miss Jackson,
Is this what she just said,
That's a
Jennifer?
great way to do it too. That's also a great way to check. I want you to continue to use different properties. So distributive property, there's the associative property, maybe definitely the commutative property. Great, Jennifer.
But then what do I do for these?
So is this equal to our target expression? Yes or no?
Wait, where's our target expression?
On the board, 2n plus 2.
2n plus 2, let's see. No.
No, so put in no. Keep going.
Wait, but how do you do these? I'm still confused.
So this is the one that we started with, right? So this is obviously yes. There were different students at different classes started with different ones. So I just put that one on there. You tell me about this. Is this, Nayeli, number 2? Is number 2 equivalent to our target expression? You say no. Why not?
Because if n plus n equals n plus n equals n, so
Wouldn't n plus n equals 2n? 2n?
Yeah. So I have I have n plus n, that's 2n.
and then
So write 2n,
2n plus 2,
and then what's left?
and then
Oh yeah, I think it is.
Yes, correct. Yes.
Yes. Very good. Keep going.
Yes.
Yeah.
Sama. Yes.
So what strategy are you guys using?
If you put n plus n equals 2 plus
Is everybody
Yeah,
using
look,
the
I'll show
strategy?
you. 2n plus n equals 2n.
equals 2n. Yeah.
Wait, Nayeli, what about this? Oh, that's the, okay, yes, yes.
I'll get 6. Yeah, that's a great strategy. You? Same thing. So I'm going to challenge you, now that you use that strategy, however many times you use it, to use what we know about collecting like terms, and to use what we know about the properties we talked about yesterday, the distributive property, the commutative property especially, to simplify these expressions. Think about, like, you don't have to erase what you've done, but, you know, the rest of them.
So then the distributive property would be like n plus 2 and then plus
Right. And then 2 times n is 2n. And then 2 times 1 is 2. So that's why this is equal. Yeah. So is this circle mean a yes? Yeah. Okay. And the x is made no. Okay. And so your strategy worked. We found that it was 4. And then the strategy we just talked about, collecting like terms, also works. Okay, great. All right. We have about 2 minutes. Yes.
Where do you get 6? 2 plus 4 is 6. What is your
There you go. We use the distributive property. Yeah.
I'm showing you.
He said it's 4.
Great. Great job. That's the distributive. You use the distributive property.
That equals 4. That equals 3. 3 times 2 is 6. Oh my god.
Just watch. Look, you said plug in n is 2. And look what we did yesterday. We multiplied that.
Yeah.
So 2 times 2 is 4 plus 1 is 5.
Oh, but don't forget.
Parentheses.
Don't forget. There's the distributive property here. Remember we talked about this yesterday? Where A times the quantity B plus C, right? The distributive property tells us that we have to multiply this number by both of these numbers. So did you do that here?
6 is yes.
You did?
2 times n, which you said plug in numbers 2.
Okay, so I mean if we plug in numbers, right? So maybe this will be 4.
Yes. I don't think so. 3n plus 5 is 10.
2 times 1.
Take away n.
And there it is. So was next one right? Oh man.
We're right. Was Sherry right, first of all?
Yeah, it was Terry, right? You were right.
I hear you guys fight.
But she showed you first.
Yes, you showed me and I showed you and you said I was wrong. So you just say that I'm wrong.
Oh, so if we plug it in, we're not really using the tree. No, we might be using the commutative property application. It's not the tree. I'm fine if you plug it in. I would love to see it. Let's see it.
Just erase it.
Number 6 is
Yes, and you said yes, and
because this is
great. Yes.
because we had 5
That's what I got. It's just
Oh yeah, that's right. That's all.
so that is
We have 5 minutes.
This is what I did. So I used the
Okay.
So I did 3 times 2 plus 5 minus 3 minus 3. So 3 times 2 is 6. 6 plus 5 minus 3 minus 3. 6 plus 5 is 11 minus 2 minus 3.
Great order of operations.
11
Yeah.
minus 2 is 9. 9 minus 3 is 6.
Wonderful. Now, I wonder if there's another way to do this because you plugged in that fine I have a table. Yes, that is yes. Let's see if we can use some of our other strategies. So maybe we can collect like terms.
3n and then
3n and n. These are like terms, right? Okay, use that strategy. Keep working. Use that strategy, Selma. I want you to use the 3 and use that strategy. Okay. Jennifer, come. Are you in the middle of something? Okay, you're checking. Okay.
Jennifer said this is what she did.
So let's look at like terms, right? I see you put a little arrow, I mean like a little rainbow here. I have N and I have a minus N. If I rearrange these guys so the like terms are right beside each other, and you can do that. It's like the associative property of addition. I can move things around into different groups. So if this is,
They had 5 plus 4 plus 5 plus 1
It's yes.
right.
This one,
So tell me what this equals now.
2n plus
What does it say?
Let me check.
minus n.
What's n minus n? 1 minus 1.
Yes.
10 minus 10. 8 minus 8. This is 0. This is 0. What's 1 minus 1? 0. Okay, tell me about that. All right, ladies and gentlemen, let's bring back to the large group. We're going to run out of time, and I had a quiz for you, and I know you love quizzes. So let's have everybody's attention this way. You might still be working. I think a lot of you are finished. Let's do some checking. So the moment of truth.
1.
This is just check yourself. Check it out. You need to check.
Yes.
You did. You checked with the other people. Check with me. You did. You checked that? How did you check that? I just put that there. Double check. Double check. Double check, please. You did okay?
Yes. No, yes. Okay, I got like 75 wrong.
How many do you get wrong?
I didn't do this one, so this doesn't count. 2, 7.
We'll talk about the ones you got wrong.
No.
Oh, that's a good one to talk about. Okay, so let's have a conversation about this, Maxwell, about math. So let's make sure people are where they belong. You're at a seat. And is there one that you had a question about? Just one. Denise.
9.
Number 7. Why is number 7 yes? Why is number 7 yes, Ronald?
Number 7 is yes because let's say you're using 2 or 5, which I use 2. 3 times 2 is 6. 6 plus 5 is 11. Minus,
I'm sorry. Go ahead. Sorry.
minus 2 is 9. Minus 3 is 6, which is the amount of toothpicks. But if you're using 5, 3 times 5 is 15, plus 5 is 20, minus 5 is 15, minus 3, which is 12.
So in other words, you plugged in a number and you got, if I was at shape number 2, I would have 6 toothpicks. And so you checked it with your table. So that's one way to know that that's correct. I wonder if we can just maybe use one of our properties, the commutative property, or maybe the associative property of both of addition, just to collect some like terms and rearrange these. What do you think, Salma?
So for number 3.
So 7. Let's continue to talk about 7.
Okay, so I was using, what I used for 7 was, since like I couldn't really like put parentheses, let's say you put parentheses around 3n, yeah, because it will be multiplication, and multiplication does come first.
Let me write here. I'm going to write what you said, because I think you can move them some. I think you can rewrite this expression to say, I here, 3n minus n, and then plus 5, and then minus 3. What do you think about that?
Yes.
That's okay, right? Because this is still a positive 3n, that's still a plus 5, this is still a minus n, and that's still a minus 3. So it's okay that we rearranged it that way. So the associative property of addition, pretty much. Okay, keep going, Tom.
And then after that, I would like plug like Ronald was using.
You would plug?
Oh no, sorry.
You don't have, I mean you can, but would anybody do anything different?
Yes.
Wait, for what? Like,
Yeah, instead of plugging and chugging. What would you do, Amber? Ariana? Just simplify. So tell me what to do to simplify.
You would do. It's hard because it's like variables and like.
Jennifer, what do you think?
Like how to solve it.
How we're gonna simplify it.
So same thing as solve, right? Kind of. With the okay. For starting with the 3n, we would, since n and n equal. Yeah. So we could just. It's just like 3n minus n, and 1, since we're subtracting 1n, it would be 3 minus 1, which is 2n.
Right.
Plus.
So I've got 3 n's. That's what 3n means, right?
Yes.
Cosentinos, that's what 3n means, right?
Yeah.
3 n's. And then I'm taking away an n. So how many n's do I have left over? 2. I have 2 n's. 3 n's minus 1 n is 2 n's. And then I know you know, so this is maybe where you got a little stuff. What's 5? What's 5 minus 3? 2. Is this expression the same as our target expression? Yes. It is. Okay, so we did a great, y'all did a great job. I'm really proud of you. Listen.
Thank you.
We're going to have your exit slip later, but let me just ask you one question. What were some strategies? Can you name some strategies you used to find out if these expressions were equivalent? So in other words, if we go back to our focus question, how did we know those expressions were equivalent? Turn and talk for like 30 seconds.
Because if we simplify it, because when you simplify it, then you'll find out it is
what we call that.
It would be harder to find that.
Yeah.
That's a good point.
And that's how we simplify it, then you find the answers easily.
Okay, so let's hear from a few people. Should I do SB60 or volunteers? Volunteers. Okay, so let's hear maybe from just 2 or 3 groups. What's one strategy you used to summarize, Jennifer?
Oh, I didn't say strategy. I said how we knew how.
Oh, okay.
Yeah.
How did you know whether the expressions were equivalent?
Oh, okay. So once we for a question, once we answered the expression, once we answered the expression, then we after we simplified everything, that's how we looked back at the at Kaylee's answer, and then we checked if it was the same, kind of the same thing. Simplify.
So I heard this word simplify, and that's a great way to think about it. So we can simplify using what, Sherry? Wait, don't move.
The variable.
So using the variables. Anybody, what do we call it? What do you say? What do you say, Nayeli?
Associative property.
The associative property, yes, we definitely use properties. Enrica? We use the distributive property. What do we do with those terms? What kind of terms?
Inequality.
Inefficient terms.
Unlike terms.